Hi everyone. In this video, I'm going to provide a demonstration of how to generate results associated with process model number 7 using Andrew Hayes process macro with RStudio. So the model that we are running is essentially this one right here. There's actually a covariate that we will be adding as well. And I'm mainly going to be focusing in on the how-tos, so to speak, in terms of specifying the model using the process macro and generating output. I actually have a link to a site where you can obtain a lot more detail on the interpretation of the results. So we are really mainly focusing in on just the basic how-tos in terms of generating results. So this particular data set that we're going to be working with is associated with an article by Zhao et al. From 2016. And we're not actually going to be testing that particular model. We're going to be testing this particular configuration of variables right here. But you'll see that we have, in this model, we've got burnout basically serving as kind of our X variable or independent variable. Anxiety is serving as our Y or dependent variable. Positive coping as a proposed mediator within the model. And then we have extroversion with that arrow pointing from that box to the arrow from burnout to positive coping. Basically, extroversion is serving as the proposed moderator in our analysis. So path A, we could say, is going to essentially be a conditional direct effect of burnout on positive coping, where the effect of burnout on coping varies across levels of extroversion. And then also we could talk about the indirect effect of burnout on anxiety as being conditional as well. And again, that is being moderated by extroversion. So let's go ahead and open up RStudio, and we'll go ahead and generate our output. Okay, so here we are in RStudio, and the first thing that you have to do is you need to obtain a copy of Hayes process macro and open it up and activate it. So I have another video where I do that, and if you don't already know how to do that, I'll include a link to that underneath the video description. So this is basically the macro in the top pane, if you will. All you would need to do is to right-click, click on select all, and then click the run button in order to activate it. And I've already activated the process macro. It does take a couple of minutes in order to finish the activation process, but once it does, you'll see down below it's basically indicating that the macro is ready to use. So the first thing that we're going to do is we're going to import our data. And briefly, I'll show you something else too. If we go under the session tab right here and go to set working directory and choose directory, what I want to do is to point the directory to the file on my computer that actually has the data set. So this is it right here. I'd already had it set up. So I'm going to click on open right here. And the next thing is to import our data. So we'll go to File, Import Data Set, and we'll go to from Excel right here. So I'll click on that, and we'll import our data. So I'll click on Browse, and in this file, there's an Excel file, and we'll just click on Open. And once we see this, we'll click on Import, and it's ready to go. So I will include a link to that Excel data file underneath the video description, so you can also be using that as you follow along. So at this point, the data file has been imported, and we have a new data frame, which is actually going to be called basically the same thing as our original data file name, which was moderated underscore mediation underscore example underscore sub. Okay, so it's a long name. So the next thing that I want to do is I want to basically generate my output using the process macros. So a really easy thing to do is if you go up to File, click on New File right here and go to RScript, you'll see that our pane kind of opens up in the top. So you can see we can kind of actually toggle between these different panes right here. And we want to be under this one right here and write our code. And one of the things I generally prefer to do, I don't I'm not a big fan of using really super long names. So what I'll do is I'm just going to resave the data frame under a new name. I'm going to call it MM data. We'll put an arrow right here. That's just a less than sign followed by a hyphen. And then I'll type in the name of that data frame. So the current working data frame is this one right here, but I'm just saving it under a new name just to shorten things up a bit. And sometimes that can be helpful when you're referencing variables within a data frame and so forth. So at this point, I'll go ahead and just highlight this and click on run. And so now our data is saved under this additional data frame. So if we just type in strmm data, we can look at the structure of the data. And you can see that we have basically, there's our extroversion variable, neuroticism, burnout, positive coping, negative coping, and anxiety. So those are all the variables that are included. And you'll notice that they're all registering as numeric. Okay, so at this point, we're going to go ahead and specify our model, our process model. So I'm going to use the function process. So that was written for the process macro. Next, we'll type in data equals, and so this is our data argument. We're going to set this equal to the name of our data frame that we're working with, which is going to be MM data right there. Then comma, and then we'll type in y equals, and then inside the quotation marks, we're going to type the name of our dependent variable within the model. And you need to make sure that when you're typing in the variable names that you're referencing, that they are exactly the same as what you have contained in your data frame. If it helps, you can kind of go back under this tab right here, and you can see the names of all of our variables in that data frame. So at this point, we're going to type in anxiety right here, inside quotation marks, then we'll type a comma, then we'll type x equals, and then the name of our independent variable, which is going to be burnout. So however, the name in the data frame is actually burn, not burnout. So include that in quotation marks, and then following that, we're going to type in the name of our proposed mediator. So we're going to type in M, so we're using the M argument, equals, and then inside quotation marks, we're going to type in pos coping or positive coping right there. So again, just taking a quick look, you can see our variable POS COP. That's what we've spelled out right here. Okay, so then following that, we'll type in the name of our moderator. So in this case, I'll type in W equals, and inside the quotation marks, I'll type in EXTRAV for extroversion. All right, so then following that, we'll type a comma, and then we have to specify our model. So in the process macro, there are a lot of different templates that you could theoretically use to model your data. And the template that we're working with right now is model 7. So I'll type in model equals 7. Okay, so basically this is just a first stage moderated mediation model that we are testing. Then comma, and I'll type in CONF for confidence intervals, and we'll set this equal to 95 for 95% confidence intervals. We'll type a comma, then on the next line, we'll just, I just went ahead and hit enter right there and went to the next line, and we'll type in boot equals, and so then here you specify the number of bootstrap replicates. So in this case, I'm just going to use 1,000 right here. You know, a lot of people prefer more. We're just going to stick with 1,000 for this particular demonstration. We'll type a comma, and then we can type a seed number. So if we type seed equals 1, 2, I'm just going to use 1, 2, 3, 4, 5. The reason why the seed number is important is because without it, essentially there's sort of a pseudo random number generator that's used in terms of doing the bootstrapping. And what will happen is that if you run the analysis one time and then you run it again, the bootstrap confidence intervals will tend to be different from each other. Not much different, but they'll tend to be different. And so folks sometimes get a little irritated with that. So if you use a seed number, you'll end up with the same confidence intervals across multiple, trials, so to speak, with your same data. So that's the basic idea. So the next thing we'll do is we'll type in our covariate in our model. So I'm going to use the COV argument, set that equal to, and then there's really a couple ways to do this. I could type in quotation marks NEUR. That's the name of our neuroticism variable. If you had a list of covariates, then another alternative would be just to use the C function right here and then type in the list of those covariates inside quotation marks and then also separated by commas. So for this, I'll just go ahead and type in NEUR. This works the same, but if I had another one, I could type in a comma here and then type in a new another covariate name and so forth. But we're just going to leave this with a single covariate right here. So then the next step, we'll type in center. I'm going to set this equal to 2. And so what this is going to do is it's going to essentially mean center our two, basically our X and our W variables. So in a nutshell, yeah, well, there it is. It's just going to be performing mean centering on those two variables. And just really quickly, the reason why I chose 2 right here is my general preference. If you happen to have a continuous by continuous variable interaction that you're specifying, if you set this at 1 or 2, either of those, it's going to work exactly the same. If you happen to have one of your variables is a dichotomous variable and the other is continuous, if you set using a value of 2 right here, then it'll only mean center the continuous variable, but the dichotomous variable would not be mean centered. So my general preference, if I had a dichotomous X or W variable in our model, would be not to perform the mean centering. And so that's why I'm just kind of leaving this as a default of 2 right here. So then our next step, we're going to type a comma. And then following this, we're going to type in plot, and I'm going to set this equal to 1. This plot option, when you set this equal to 1, what's going to happen is that it's going to generate basically values associated with your X and W variables and then predicted values on the dependent variable. And so you can use this for plotting out simple slopes. So that's the reason why this is in here. Following this, I'm going to type in int probe, and I'm going to set this equal to 1. And what this does is basically, in the context of our model where we only have that first path being moderated, the first equation that is going to appear in our output is essentially a moderated multiple regression. And so if the interaction is statistically significant, we would typically follow up that interaction by looking at simple slopes and testing them out for statistical significance. If you set this equal to 1, it will always generate the simple slopes, whether the interaction term is statistically significant or not. And I just generally prefer to have that irrespective. Not that I would necessarily utilize it as a follow-up, but a lot of times I just tend to prefer to look at it. So there it is. If you just wanted it to be based on alpha level of 0.05 for the interaction and just show up simple slopes following a significant interaction with, again, alpha at 0.05, you could just type in 0.05. So at this point, we have everything we need to in order to run our analysis. So at this point, I'll highlight all of this and click on the run button right here. And you can see that we've generated our output. So just kind of briefly, we'll just take a quick look at it. Most of the heavy duty discussion of the results is you can find by following the link that's provided underneath the video description. But just kind of showing you, you'll see that we have up above, or the first part of our output, you can see we have just a description of our model here. So you see we've got model 7. We've got our Y variable, X, M, and W variables right there. There's our sample size. And then there's the custom seed that I was telling you about before. So we'll scroll down a bit. And the first thing we'll look at, we've got the first equation. And as I mentioned before, this is essentially a moderated multiple regression where our outcome variable is the mediator in our full model. So this is positive coping. You'll see we have our R-square value right there. We have our F-test, and you can see that we have, there's our degrees of freedom, regression, residual, and then also p-value that indicates statistical significance. So as a set, all of the predictors in the model are jointly accounting for about 12.7% of the variation, and it's statistically significant. When we take a look at the predictors within the model, you can see we've got the burnout and extroversion right here. You can see these are the regression slopes, and you can see that both of these are statistically significant. Just keep in mind that in the context of our moderated multiple regression, that the effects that you see for each of these are really simple slopes. They're not main effects as you would talk about in the context of a standard analysis of variance, but rather the slope for burnout, that is the slope or the predicted slope for a case falling at 0 on the moderator, which is extroversion. And because these variables have been mean centered, that would be this slope right here of negative 0.2149 is the slope for the predicted slope for cases that are falling at the mean on extroversion. You can see that that is statistically significant. Then with respect to the extroversion variable right here, this is the slope for cases falling at essentially the mean on burnout, because again, burnout is centered at around its mean. So you can see there's a positive slope right there. When you look at the next piece of the output right here, you have the interaction effect. So it's 0.2698, and you can see we have statistical significance, which is basically indicating that we have evidence that's consistent with moderation of that direct effect of burnout on positive coping. And you can also see we have our little neuroticism variable down at the bottom right here, just having a negative but statistically significant predictive relationship with positive coping. So when we scroll down a little bit further, you'll see that we've got the conditional effects of the focal predictor at values of the moderator. And by default, process is going to use the 16th, 50th, and 84th percentiles of the moderating variable. And actually, in this case, the mean-centered moderating variable. So what you have right over here, these values are at the 16th percentile, at the 50th percentile, and at the 84th percentile of the centered extroversion variable. So these are the simple slopes associated with each of those locations on the extroversion variable. So in other words, the simple slope or for the effect of burnout on positive coping for individuals who are falling at the 16th percentile on extroversion, that simple slope is a negative 0.3205, and you can see that that's statistically significant. Then at the 50th percentile of extroversion, the simple slope for burnout is negative 0.2049, and you can see that that's significant. And then at the 84th percentile, it's negative 0.1278. That is also significant. Now, the fact that we have significance for all those is not really problematic. Basically, we just see that there are significant negative effects. But the thing to notice is that the slopes right here are not constant across levels of extroversion. And so in this particular case right here, we see that the slopes are becoming less negative as we move from lower levels of extroversion to higher levels of extroversion, which is consistent with what we would expect potentially when we have moderation. So when we scroll down a little bit further, you can see that we have this area right here. It says data for visualizing the conditional effect of the focal predictors. So there it is. And unlike using SPSS, where you can kind of generate plots of the simple slopes and so forth, it's a little bit trickier in the context of RStudio. And so I'll kind of show you how to accomplish this plotting in a bit, but we do need this information to accomplish it. You'll see next we have our second regression model where we have anxiety being regressed onto burnout, positive coping, and then also onto neuroticism. So burnout, this effect right here, this is the direct effect of burnout on anxiety within our model. We also have the direct effect of positive coping on anxiety. So this is basically, that's your path B, if you will. So this is the slope. You can see there's a negative and significant predictive relationship between positive coping and anxiety. And then we have neuroticism kind of coming back in there as our covariate. And you can see there's a positive and significant predictive relationship there. So when we scroll down, you'll see that we have two sets of information to pay attention to in particular. The first thing is that we have this index of moderated mediation. So if you think about it, the basic idea is that when we're if we take the path A, just in a regular mediation model, if you take the path A and multiply it by path B, you get an indirect effect. But because our path A is conditional on the level of extroversion, you could think about it as having 3 path A's, if you will, that theoretically would be multiplied by path B. So we have 3 effects that would be conditional effects. And we could actually generalize that out across many, many levels of extroversion. But the point is that when we have in this particular case, we have conditional indirect effects. So in your output right here, you'll see that we've got, extroversion at essentially the 16th percentile, 50th percentile, and 84th percentile of the centered extroversion variable. And these effects right here are essentially conditional indirect effects. So in other words, if I take the conditional direct effect of burnout on positive coping, where extroversion as falling at the 16th percentile, this would be the conditional indirect effect right here. At the 50th percentile of extroversion, this would be the conditional indirect effect. And then at the 84th percentile, this would be the conditional indirect effect. So the index of moderated mediation, what it's basically addressing is variation in these conditional effects across levels of extroversion. And so if we find that there's significant variation in those effects, then that would be an indication that we have moderation of the indirect effect. So the index of moderated mediation is essentially a test of moderation of the indirect effect. So the index that you have right here is it says negative 0.0345, and you can test this out by using the bootstrap confidence interval that's provided right here. So we have a lower bound and an upper bound of our 95% bootstrap confidence interval. And basically if 0, which is the null, if that falls between the lower and the upper bound, then in that particular case, that would be evidence that we do not have significant moderation taking place. If 0 falls outside of the lower and the upper bound, then that would be evidence that we have significant moderation of the indirect effects. And so you can see right here that 0 is falling outside of the lower and the upper bound of our bootstrap confidence intervals. So that you can think about this right here as essentially a test of the omnibus effects. Overall, is there evidence of moderation of the indirect effect taking place? And then if you want to further kind of look at several specific conditional indirect effects, then that's where you can go up to this particular part of our output. So again, this would be the conditional indirect effect of burnout on anxiety at the 16th percentile right here. And you can see that this effect, we can test this using the same logic that we applied down below with the index of moderated mediation. So right here, you can see that 0 falls outside of the lower and the upper bound. And so that would be basically we have a significant indirect effect through positive coping for cases falling at the 16th percentile on extroversion. Then there's our conditional indirect effect at the 50th percentile of burnout, or excuse me, of extroversion. And you can see that is also going to be statistically significant. And then in terms of at the 84th percentile of extroversion, we have our indirect effect, and you can see that is also statistically significant. So basically what we have right here is we do have evidence of moderated mediation that's taking place. So the other thing to ask then is about that, generating those simple slopes. So if you go back up here, remember that our path A, we had already discussed, has evidence of conditioning based on level of extroversion, and we have this set of data right here that we can use in order to generate a plot. So a lot of times people want to plot out simple slopes and include that in articles and so forth. So we need this information that's provided, but there's no quick, expedient way of generating plots. So I'm going to show you just a quick, simple version of how to obtain this, to obtain a plot. So the first thing is you're going to need to use the ggplot2 package. So I've already installed it. So I'm going to use the library function and call it up. So I'll type in library ggplot2, and then just basically activate it. So I'm going to highlight this and click on run, so it's ready to go. So then the next step is going to be to create a data frame that contains that information that we have. So kind of going back right here, I'm going to create a variable that I'll call essentially burnout, one for extroversion and one for positive coping. And what you see right here, you'll see that we've got burnout. This is this value right here is at the basically at the 16th percentile of the centered burnout variable. This is at the 50th percentile, and this is at the 84th percentile for the burnout variable. And you'll notice that it just kind of repeats all the way through. So there's the next three, and then the following three down below. Then we have extroversion, and so you'll see that we've got negative 0.3914, negative 0.3914, negative 0.3914. That is at the 16th percentile for our centered extroversion variable. Then we have values, the value that's falling at the 50th percentile, and then we have the value that's falling at the 84th percentile. So you'll notice then that we have for our positive coping variable right here, these are predicted values at each combination of burnout and extroversion. Okay, so that's basically what's happening. So we need to create a data frame that contains all the information in these three columns. So I'm going to create one. I'm just going to call it DF for data frame. Type in an arrow right here, and then we'll type in data.frame. And inside parenthesis, I'm going to type in the burnout variable. And actually, just to be more descriptive in my plot, I'll type in BURN_C for this indicating that's centered. I'll type in a equal sign, and then we're going to create a list of values that are in that column. So I'll use the C function right here, and I'll type in negative 1.2135, comma, negative 0.0317, comma, and then 1.0593, comma, and then basically these are the same values. They're going to repeat all the way through. So just to kind of make things a little bit quicker, I can just type those in as such. So there you go. Then we'll type a comma and then go to the next line, and then we'll do extroversion. So I'm going to type in an EX TRAV underscore C as well, just to indicate that we have this variable being centered. And then we'll type in equals. We'll use the C function, and then we'll type in those values. So we have negative 0.3914, negative 0.3914, negative 0.3914. Then we have 0.0372, and so forth. And I'll also do the same thing with positive coping. I'm going to pause this just briefly and finish this out. Okay, so now I have all those values typed in. And so then the next step is, we want to generate our plot. One of the things that we're going to have to do, though, before we generate our plot is to treat this extroversion variable as a factor variable. So right now, and by the way, I need to go ahead and highlight this. We'll click on Run. And if I take a quick look at the structure, we'll just use the str function right here, df. You'll see that with this, all three of our variables are being treated as numeric, and we need extroversion to be treated as a factor variable. So what I'm going to do is I'm going to type in df, that's the name of our data frame, df $, followed by the name of our variable, which is extrav_c right there. So we're referencing the extroversion variable in this data frame. We'll type in our arrow, and then I'm going to use the factor function, and then we'll type in basically the same thing again. Okay, so basically we're converting the extroversion variable to a factor variable. So if I run this, you'll see it's, nothing shows up, but I'll show you again. If I use the structure function, we'll just take a quick look at it, and you'll see that now it's being registered as a factor variable. So then the last step in all this is essentially to use the following command. So we'll type in ggplot, use that function. We'll reference our data frame, which is df, comma, then we'll type in AES, there's another function. We'll type in x equals, and then the name of our variable in the data frame, which is burn_c, that's our x variable, then comma, y equals, and then we'll type in positive underscore cope. So that's this variable right up here that we had added before. And then following that, we'll type in a comma and then use the group argument right here, set that equal to the extroversion variable, extrav_c right there. So then we have our in parenthesis, we have another in parenthesis, and then we'll type in plus, and then we'll type in GEOM_line. Then inside parenthesis, I know it's a lot, but we'll type inside the parenthesis AES, and then start another parenthesis inside. We'll type in line type, and we'll set this equal to the name of our moderator variable again, which is our extroversion_c variable right there. And then finally, I'm going to add another plus. We're going to go ahead and go to the next line, and then we'll type in GEOM_point, and then our parenthesis there. So it's kind of a mouthful, but basically when we highlight all this and click on Run, we generate our plot, which is this one right here. So you can see that the points are basically associated with those combinations of value levels on our focal independent variable and our proposed moderator, and the actual points are basically associated with the positive. These are the predicted values on positive coping at each combination of our x and w variables. So there you go. There's our plot of the simple slopes for our analysis. So that is pretty much going to wrap up this video presentation. Again, be sure to check underneath the video description for the links that I was referring to throughout this video. And I appreciate you watching.